Next, we'll formulate the construction stages for this bridge to perform the construction stage analysis. So as you know, construction stage analysis is crucial for this type of bridges where each temporary structure arrangement can lead to critical internal forces in specific members, and the structural behavior such as deflection and the stress redistribution will continue to change during and after the construction due to varying time dependent properties such as creep, shrinkage and modulus of elasticity change of the concrete, as well as the tendon relaxation. So all these effects we need to simulate to check whether our bridge is safe during the construction process. As I mentioned before, we'll be performing the construction stage analysis using this structured boundary and load group in MIDAS Civil. So you can activate and deactivate the element, boundary and load groups, so thereby you can form the different stages. So in total we have 6 construction stages for this bridge. In CS1 the duration is 1 day, where my pier and pier cap would be activated at the age of 28 days, and the substructure supports and the sulfate would be activated in this stage CS1. In CS2 the girders of the span 1 would be activated, and then span 1 would be supported on the temporary supports, and the pre-stressing would be done for the girders of the span 1. In the CS3, where the duration is 21 days, so the diaphragm of the span 1 would be activated at the age of 14 days, and the girders for the span 2 would be launched, and the previous span 1 girders which are on the temporary supports would be deactivated, means the temporary supports would be deactivated and would be switched to the bearings, permanent bearings, and girders of span 2 would be on the temporary supports. In the load part, the casting of the slab of the span 1 would begin at the age of 14th day of CS3, hence the wet concrete load of the slab would be acting on the girders of the span 1. And then in CS4 you have 21 days duration, where the temporary supports of the span 2 would be deactivated and the span 2 girders would be switched to permanent bearings, and these are all the loads that would be acting in the respective construction stages. And in CS5 the deck slab for the span 2 would be activated, and the load, wet concrete load of the span 2 would be deactivated in CS5 itself. And at the end of CS5 our construction process would be completed. Then in CS6 we'll simulate the whole bridge for 10,000 days to accommodate for the long-term stresses due to the time dependent effects. So these are all the construction stages that we're going to define in the subsequent steps. So in CS1 the substructure, CS2 the girders which are laid on the temporary supports, then the permanent bearings for the span 1 girders, then the span 2 girders on the temporary supports, pre-stressing would be done. In CS4 the wet concrete load which would be acting would be hardened up, and the composite action would kick in CS4 for the span 1, and CS5 which would be the complete bridge at the end of CS5. So let's define the construction stages. For that I'll go to construction stage, click on define construction stage. Here I'll click add. So I'll give the name of the first construction stage as CS1. As the duration I'll take as 1 day. So here in CS1 the duration would be 1, and these are the structure, boundary and load groups that I'm going to activate to formulate CS1. So here you have element, boundary and load group. So these are nothing but structure group, and boundary indicates the boundary groups that we have defined, and the loads, the load group. So first CS1 substructure and support. So thereby you can activate and deactivate the element, boundary and the load groups to make up the stage. So I'll click on CS1 substructure and support. So this would be activated on the first day of the construction stage CS1 with a concrete maturity of 28 days. So this would be the concrete age. So I'll click add. I'll go to boundary tab, and add the substructure supports. So original and deformed, the deformed configuration it would be added. So I'll go to load. I'll add the self weight on the first or the last. So I'll select first day, the self weight would be acting. So I'll click on add. So whatever the element boundary and the loads that you activate would stay activated, so on till you deactivate. So this is CS1. I'll click OK, then I'll add, give the name as CS2. Here I'll activate the element group which is span 1 girders at the age of 21. Click add. I'll go to boundary. I'll add span 1 temporary supports and the rigid links for the span 1. So here next I'll go to load tab. So here I need to add the relevant loads which would be coming on the CS2. So here the duration of the CS2 would be 21 days. So in CS2 the girders of the span 1 would be stressed in sequence like the first, second and the third layer. So for that here if you see the span 1 active day, it would be the first and the last. If you wanted to simulate the time in between, so you can add the additional steps. So I'll take 0.3 day and 0.6 comma 0.9 and click on add. So now this would be visible to choose. So I'll click on span 1 PS1. The first layer of the pre-stressing would be stressed at the 0.3 day. That means 0.3 day. I'll click add. Similarly, span 1 second layer would be stressed after some time, so I took it as 0.6 day. I'll click add. Similarly, this would be at the 0.9 day. Click add. So this is how you can create the additional steps for the loads which are coming in between the first and the last day of the construction stage. So you can appreciate how powerful the software is in simulating the construction stages. Next I'll click OK. So CS2 is defined. Next we'll define CS3. Duration as 21 days. Diaphragms would be activated. Span 1. Diaphragms would be activated at the age of 14 and the girders at the age of 21. In the boundary tab, so here in CS3 the span 1 girders would be switched to the permanent pairings. So we need to deactivate the span 1 temporary supports. In this deactivation dialog, I'll click add. So the span 1 temporary supports that have been activated in the previous construction stage CS2 would be deactivated on the first day of CS3. So here the bearings of the span 1 should be activated and the span 2 temporary supports would be activated and the corresponding rigid link. In the load tab, the wet concrete of the span 1 will be acting on the 14th day, where the casting starts on the 14th day of CS3. So we need to add the 14th day. Click add. Select wet concrete span 1, select 14th day. I'll click add. And the span 2 girders would be stressed. So I'll be adding the additional steps like 0.3, 0.6, 0.9 day. So span 2 first layer of the tendons of the girders of the span 2. Click add. 9. I'll click add. So I'll click OK. Next I'll define CS4. Duration as 21. In the element group, I'll activate the span 2 diaphragms and the end dummy members of the span 1. Click add. Go to boundary tab. Here I'll deactivate the span to temporary supports, activate the span to bearings, and in the load tab we'll create the 14th day additional step, and I'll deactivate the wet concrete load, where in this stage the concrete gets hardened for the span 1. So the deck gets hardened in the span 1 so that the composite action will kick in. So we need to deactivate the previously activated wet concrete load for the span 1. I'll deactivate. I'll click OK. Next I'll define CS5. At the age of 14, span to dummies would be activated. And then there are no boundaries to activate, as the previously defined activated boundaries would stay active till we deactive. So in this load tab, wet concrete, the span 2 we need to deactivate. Click add and click OK. Next we'll define CS6, the last construction stage, so which includes 10,000 days duration to simulate the time dependent effects. So here in the load tab I'll activate the superimposed dead load on the first stage of this construction stage, and thereby the software will simulate the time dependent effects for the 10,000 days. Click add, and the crash barrier load add. Click OK. So these are all the construction stages that we have formulated for the bridge. Click close. Now let me visually represent the defined construction stages. For that I'll go to display options. So here I'll go to boundary tab, select all of them, and go to load tab, select all of the loads and click on apply, click OK. So now all of the loads and all of the boundaries would be simultaneously displayed. Now this is the tab to switch between the construction stages. Base is where we have defined like all the information regarding the model, and then we group them under CS1, CS2 till this CS6 construction stages. So let me switch one by one. So this is a shortcut key for define construction stages. Go to load construction stage. These both are same. So I'll switch to CS1 first. So this is how my CS1 would look like. The substructure would be activated. In CS2 the girders would be laid on the temporary bearings and the pre-stressing would occur, and then CS3 wet concrete load would be acting, and the diaphragms of the span 1 would be casted, and the girders would be switched to the permanent bearings. Whereas for the second span you have the temporary bearings and the girders, and the pre-stressing would be done for the second span. Next I'll go to CS4. The wet concrete load gets deactivated, and in this CS4 the composite action should kick in, but we did not say in the define construction stage to tell the software that the composite action occurs in CS4. You have a separate option called composite section for construction stage. By this feature will let know the software that the composite action should start from CS4. So in CS4 you have the wet concrete load for the second span, and in CS5 it gets hardened, and at the end of CS5 the bridge would be complete, and in CS6 will simulate for the time dependent effects. Then let me undisplay them. You can quickly undisplay from clicking reset all. Click OK. I'll go to base.